Yeah, my name is Oscar Diez. I am the Deputy Head of Unit of Quantum Technologies at the European Commission, and I'm based in Luxembourg. So I've been invited to basically to give a talk. I will have it in a few minutes, and I will talk about more or less what we are doing in quantum technologies at the European Commission. As you know, we have been working in quantum technology since a long time. We launched in 2018 the quantum flagship, and now we launched this year we announced the quantum strategy. And we are currently working in the quantum. Quantum physics has a lot of applications. So basically, at one moment, a few years ago, it was mainly, let's say, research-based, and it was what we call low TRL. So it was more basic science. But now, in the last year, we have seen a lot of different applications. We divided, from the quantum flagship, we divided like in different pillars. One is related, everything that is related to quantum computing and simulation. And it has a lot of promises there from the point of view of improving using different type of algorithms to improve problems that currently cannot be done or are extremely difficult to run with even supercomputers. We have also quantum communication, that is everything that is related to secure communications, and we have some examples, like for example what we are doing with the deployment of EuroQCI, that is a quantum key distribution network. So basically it's a secure network that we are starting to implement it at European level with critical infrastructures. And we have later everything that is related to quantum sensing and metrology. And here we have quantum sensors. We have a good example because we have a company here, Diez, that is a French company, that are working on sensing, on quantum sensing. And here where you can have different type of sensors, but the idea here is that you will have normally more precision than the classical sensors. One of the examples that we are doing, deployment of these MRIs, these quantum-enhanced MRIs into some hospitals at European level for doing preclinical trials. And one of the things, for example, is to reduce, you have more precision. So, for example, if you see the effect of chemotherapy, for example, when you are doing a drug treatment for cancer, in some cases you can bring down from 7 months to 7 days, the time that you see in order due to that precision. So at the end, the important thing is not so much if it's quantum or not. I think the important thing is how this can affect the society and what are the benefits for the society. Because at the end, a patient or somebody in an hospital or somebody that is doing secure communications, they don't care so much about if it's done with quantum technology or not. They care about is something that is a lot better or a lot cheaper or with more precision than what we are doing today. At the engineering level, there are a lot of challenges, and depends mainly on which, let's say, in which pillar are you discussing. If you're talking of quantum computing, for example, quantum computation is not only the fact that we need to have more number of qubits, but better quality qubits with more fidelity, better algorithms, error correction. If you go to quantum communication, there are also technical challenges from the point of view, for example, when you need to have long distances, because the quality of basically you are using single photons, and when you are going into really long fibers, basically it's not working properly. So you need to solve things like, for example, having what we call quantum repeaters, and in quantum sensing, because it's so many type of sensors, so there are also a lot of challenges. That is from the technical point of view. I will not say all of them, but a lot of the challenges are engineering challenges. So it's a question of how, for example, how you reduce, you have, for example, in a quantum computer, you need to increase the number of qubits. You have all the control electronics, you have everything that is, for example, all the cables that are going into the cryostat, that you will need to put more and more cables, and this is mainly an engineering problem. This is from the, let's say, technical point of view. There are other problems, especially in Europe. We have 27 member states. Each member states, they have their own proposals, their own roadmaps, their own strategies, and this is extremely good, but it's difficult to be in this race with countries or regions like the US and China if you go alone. So I think one of the main challenges that we have in the next years is to coordinate all these efforts, to pool the resources in order not to look like 27 member states, because it will be impossible to win like that. So we will need to coordinate it in order to go like Europe. There is another challenge, and this is more related to finance, basically everything that is related to to finance that is very specific in Europe. That is the fact that we have very good number of very good startups. In France, we have really good number from the number and the quality of the startups. But there is an issue when they want to scale. There is not enough private funding. The governments, the public institutions, at the national level, at the EU level, we can, and we are doing, is provided funding. But at one moment, they need to get private funding in order to scale. And we are talking about the tickets when you are going into the Series B, Series C. They need funding that it's in Europe is very difficult because we have a different mentality from the point of view of risk when we are investing. And for example, in regions like the US, that is not happening. So you have companies that maybe from the point of view, in the United States, for example, from the point of view of the technological solution, they are not as good or even they are worse than European ones, but because they have access to funding, they will be able to scale up and they will be able, even in some cases, to buy European companies. And it's something that in Europe we need to sort it out. It's the right moment to act, basically from the point of view of providing funding, providing resources, providing the right environment to the companies here in Europe in order to be able to scale those companies and to have really champions in Europe in the same way that they are starting to appear in the United States or in China, in other regions. I think we need to be positive here. We are very good in quantum, we have been very good in quantum, and we need to basically don't lose the train, and we need to, even if we can, in some, I will not say in all the technology, but in some of these pillars, try to position ourselves at real champions that we have in Europe.